The purpose of this video is to review our intra versus intermolecular forces. So before this unit, most of everything we discussed was intramolecular. So we were talking about the bonds and the interactions within a molecule or the interactions within an actual atom or an element. Most recently, we started discussing intermolecular forces. And so these are the different forces, and a way to think about them as interactions. Okay, and so this goes outside of the bond, and it kind of has to do with what's happening next to the molecule. Let's go through some of these. We talked about London dispersion. And again, with the London dispersion, we said they're fairly weak, which means compared to the energy related to a bond, right, this bond here, they're much weaker. And so what we said about the London dispersion is basically all molecules can have London dispersion forces. And the best way to think about this is as follows. Let's say we have helium. Okay, and let's say let's draw this in a simplistic manner. We have 2 electrons here, and we have right here's our nucleus with this positive charge. Now, if we have this in a container and we have a lot of these, a lot of helium in there and a lot of gas, we could imagine a scenario where these electrons and these protons are lined up in many different ways. So these are all helium. But notice, right, we know the electrons are moving around and we know these molecules are spinning around. We could have a scenario where, right, we have these 2 atoms of helium next to each other like this. Notice we have these negative charges on the electron, the positive charges on the proton. And we're going to have these little interactions here. And usually when we've kind of graphically represented these, we draw these little dotted lines and we're saying, hey, there's some sort of an interaction here. We have this negative and this positive, and so we know there's going to be a little bit of an interaction. So that is a London dispersion force. Similarly related are our dipole-dipole. And these also are relatively weak, and they are usually easier to understand. If we think about, in our previous example in one of the videos, we had HCl, and we said, aha, this is going to be a partial positive, this is a partial negative. Well, similar idea, right? If we have a lot of these molecules kind of lined up, maybe put one here, notice that hydrogen is a partial positive, the chlorine's a partial negative. We're going to have some sort of interaction here because of the negative charge of the chlorine and the positive charge of the hydrogen. There's some sort of an attraction. Notice here we're not going to have it, right? Because these are 2 partial negatives. If anything, they're going to repel each other. So dipole-dipole, we have to really think about the partial charges on the different chemicals that we're looking at in the various scenarios. And then finally, one of the strongest and the most important is the hydrogen bonding. So when we talk about hydrogen bonding, the easiest one to look at is just to start by discussing water, right? Hydrogen bonding is just so important in water. So let's draw our water molecule. And again, think about this. Let's say we have a beaker full of water, and all this water is kind of swishing around. But we can imagine these scenarios where we might have, right, kind of this hydrogen lined up next to the oxygen, and right, it's such a strong dipole interaction that we have this going on, right? This hydrogen is going to be interacting with these unbonded electrons on the oxygen. Oxygen is extremely electronegative. Hydrogen is extremely partial positive, and those where the interactions happen. Notice this is also going to occur between hydrogen and nitrogen, oxygen, and fluorine. And so it's important to remember these because these have this very strong electronegativity. And hydrogen bonding is strong. Okay, it can really impact things. And in particular, when we start talking about physical properties, we talked about boiling point. We said anything that has hydrogen bonding will have a higher boiling point. Some of the other forces that we talked about, some of the other physical properties, we talked about boiling point, we talked about viscosity, and we said viscosity is going to increase when we have strong intermolecular forces, but decreases with higher temperature. And a good example is to think about syrup, right? If we warm up the syrup, it's going to be less viscous and it's easier to pour the syrup. Another important physical property is surface tension. And this is the result of the inward experience. The inward force that's experienced on the surface of a liquid. And especially we've talked about water, kind of the beating of water, or we've talked about the example when a bug can walk across the water surface. So the accumulation of these weaker forces can add up and they can be significant. Just to review, London dispersion, all will have it, but it's weak. Dipole, not all, it is also weak. Hydrogen bonding, again, not all. We're looking for hydrogen and then nitrogen, oxygen, and fluorine. But these are very strong, so when we're there, we will notice it in the physical properties.